Terraform is declarative, right? Declarative means we just need to give instructions to Dynamo to Terraform that create this many instances. Okay, we do not tell them how to create that. They know how to create it. Okay, that is, we in imperative way we'll tell them that do like this. Okay, but in a declarative way we'll have to tell the system or Terraform that achieve this state anyhow. But it needs to store the state somewhere, right? So that's how it is stored and where it should be stored. Okay, and what happens if multiple people use the same tf state, that will be learning here. Okay, so we'll first create a new directory before proceeding with this exercise. Okay, I need to show something. Cd dot dot, or what I'll do is I'll copy the same one, cat main.tf. Okay, but I'll create it in a separate directory. I'm just copying it. Cd dot dot. I'll create one more directory. Mkdir demo cd demo cat main.tf. So if you see in this directory, okay, whatever path it may be, cat main.tf. So we have only this file at this location. If you do ls, okay, ls shows the contents of the current directory. It has only one file, main.tf. And if we do ls-al, okay, it shows some hidden directories, but nothing is there. Okay, these are some system related, we don't need those. So as of now it has only one directory, even there is no hidden directory here. Okay, and when we do terraform init, okay, when I initialize the terraform, what it will do is, for AWS provider, it will start downloading the plugins. Okay, so if you say it started initializing the plugins, okay, which are required to interact with the AWS. So Terraform initialization is done. Just do ls-al. Okay, and if you see, two files are created. One directory is created .terraform, and a lock is also created. It maintains internally this lock. Okay, and the .terraform directory has all the plugins necessary to interact with the AWS. Okay, but still this is not what we need. Okay, but I want to tell you that which file gets created when we do initialization, these two files are created. Now I'll do terraform plan. Okay, and it gives the plan that it will be creating two S3 buckets. Okay, if we do ls-al, okay, still nothing has changed. Okay, this was created when we did terraform init. Okay, now let's do terraform apply. Okay, and just do auto approve. So it will create two S3 buckets. Okay, and now just see ls-al. Okay, and we can see it created a file called terraform tfstate. Okay, so let me clear the screen. ls. Okay, so it will show this ls. Always use ls-al, then it will show the hidden files and directories as well. So this file is created. Now let's see the contents of it. Okay, so if you see, it has maintained that it has created a bucket, okay, 0. It has some ID, okay. So all the details, this is the current state, okay. This is the current state, and this is how it is declarative. It will maintain the state. This in this file it is maintaining the state, okay. Next time when I run again terraform apply, okay, so it will check this file, okay. It will check this file with along with whatever defined in main.tf, and it sees that it matches the configuration. If there is a drift means if the configuration, either the bucket is deleted, okay, someone manually deleted the bucket, or someone changed anything in the configuration file main.tf, it will see the changes, okay, and it will try to match the changes, okay. So this is all these things are maintained in the terraform tfstate file, and this file is important. If you lose this file, it will try to create a new one, okay, and it will give an error that the buckets already exist, okay, because at the AWS console the buckets already exist, and in the configuration you have defined that create two new buckets. There is no terraform state file, then it will just give an error, okay, and it will also cause some inconsistency, okay, because when it creates the resource, sometimes it creates the dependent resources as well. If the terraform tf state is lost, you will have an inconsistent environment, okay. Now due to some reason this got deleted, then again you'll have inconsistency, and in the production environment multiple people or multiple DevOps engineers will be working on the same code. So in a production environment, generally this demo folder will be stored in a GitHub. We haven't started about Git, but it will be stored in a centralized location called GitHub, okay, and multiple people will be downloading it on their system, that code, this code, and they will be working on some parts of the file, or somebody may be working on variables.tf, somebody will be working on outputs.tf, and they all will first test it, okay, and then push the code back so that everyone knows about it. But if everyone copies that code and runs the command terraform apply, all will have a different terraform state files on their system, okay. It also maintains a backup before running the next run. So this terraform state file, if multiple people start working on it, okay, they will have different terraform state files, okay, and again there will be inconsistency, okay, and that's why it is recommended to store this terraform tf state file at a centralized location, okay. So what is that centralized location in AWS? In S3 generally they store the terraform tf state file, and there is a proper syntax for it to let Terraform know that this is the Terraform TF state file, and it is stored centrally at some location, that is S3 bucket. Okay, so we'll today see how to store this Terraform TF state file in a S3 bucket. Now, even though we have stored this in a Terraform TF state file in a centralized location, still multiple people will be working on it. Okay, so suppose there are 3 developers who are working on it, and the first one started working on it first, then it will be locked till the Terraform run is completed, Terraform apply is completed. Till then, other 2 people will not be able to access the Terraform state file, and it will be in a lock state. And how that lock is achieved? That is achieved using DynamoDB. Okay, so today we'll be creating an S3 bucket, okay, and we'll also be creating a DynamoDB table. So S3 bucket is for centralized storage for Terraform TF state file, and DynamoDB for locking it, okay. And this is an interview question, okay. So the answer would be S3 is used for centrally storing the Terraform TF state file, okay, and DynamoDB for locking it. So let's start the demo. I'll just destroy it first. So let me explain this. In this, we are creating first S3 bucket and a DynamoDB table, and DynamoDB is nothing but a NoSQL. Okay. So first block is provider, then we are creating a bucket. Okay, and this bucket will be used for centrally storing tfstate. Okay, I'll have to change the name, somebody must have used it. Okay, then the second resource which I'm creating is DynamoDB table. Okay, uh, the block name is DynamoDB lock. Okay, and the name of the DynamoDB table will be this Dynamo. Okay, it will create a table with this name, and we'll see it on the screen that this DynamoDB table is created. Okay, and this bucket is created. So once this is done, that this is the prerequisite for all the next Terraform code. So after creating those bucket, we have to add this block. Till now we were adding this provider block. Okay, and then we are adding our resources, whatever we wanted to create. But now onwards, what we will do, we'll just create one more block called Terraform. Okay, and we'll define a Terraform backend. So actually, when we say that we are storing at a centralized location, we are defining a backend where it should be stored. So the backend is S3 bucket. Okay, the bucket name which we created in the earlier step, and the file where it will be stored, the bucket, and then the file, the region is there. We'll also encrypt it. Okay, so it will do the encryption automatically at the backend. Now we need to lock it as well. For that, we are saying that we have already created a DynamoDB table, use it here. Okay, so this now onwards, these two blocks are mandatory. In production environment also, we need to define a backend. Okay, so this is the one-time task, creating a DynamoDB table and backend. This we can do either from console manually or using a Terraform code. In this case, we are using a Terraform code. So let's start the exercise. I'll create the same directory structure. I've created a directory. Inside that, I'll create a code which will be used for creating. Okay, I should have used this name. Okay, let me go back again. Okay, so I'm in S3 DynamoDB table where we'll be creating S3 bucket and DynamoDB using Terraform. Main.tf. We are also using the output variable to see it on the screen rather than going in the console and checking. We'll see it on the screen itself. What is the name of the Terraform tfstate bucket and the name of the DynamoDB table. I'll just modify it. Just add 5 here. Okay. And for DynamoDB table as well, let's change the name. It may not be used, but as we have changed the name for Terraform bucket, let's also change it for DynamoDB table. So let's do Terraform init, Terraform plan, and Terraform apply. So I'm not auto approving it. We want to see it on the screen, what it will do. Then we'll approve it. So if you see, it is creating a DynamoDB table, Terraform. Using Terraform, first is creating a DynamoDB table with the name this Dynamo tfstate lock dynamo 1. Okay, and the second block it is creating is S3 bucket. The name will be this, and just approve it, and it will also output it on the screen. So it knows it the name here, but here it will calculate and give it on the screen. Okay, so what happened is bucket already exists. Again, I'll have to change the name. So many students are referring this document, and after that they are not destroying it. Okay, so they will definitely get a bill after some days because they will forget it. And if you see, these two resources are created. One is the backend bucket name, another one is DynamoDB table. Okay, we'll need this. Okay, let's copy it in a notepad. Now let's proceed with the next part, that is creating the actual Terraform code. So we already created tfstate ec2 before starting this. We'll go back one directory and do cd. Now we are in a new directory where we'll create a new Terraform file, cat main.tf. So then I'll explain this. The first, till now we were not using this block. We were using only the provider block, okay, which will download the plugins related for AWS. Then we used to create the resource. Again, in this case, we are creating a EC2 instance, okay, and we are outputting the EC2 instance IP on the screen. Okay, the new block which will start using it is this one. Okay, we are defining a backend. For the backend, we'll be using a Terraform tfstate file bucket which we created earlier. I'll replace it with these values, okay, and the DynamoDB table as well. Okay, so for centrally storing the tfstate file and locking it. So let's replace this. Only one I need to add here, and I'll copy this. I'll change it. Vim main.tf. And make it one here. Admin.tf terraform init terraform plan terraform apply. So if you see, successfully configured backend S3 Terraform will automatically use this backend unless backend configuration changes. And earlier we were not getting this output. Okay, so the other things are same. The now onwards it has started storing the tf state in the bucket. Okay, and it is just creating one EC2 instance. Just do yes for approving it. And let it finish, then we'll see the tf state file where it is created. Okay, so the resource is created. Just a minute. Okay, so now let's check the current directory. If you see, the Terraform tf state file is no more at the current location or at the local uh, system. It is now in the S3 bucket. Even if we do ls-al, it will not have the Terraform tf state file. Okay, only the plugins related directory is there. Let's go to our S3 bucket and refresh this. Okay, this is a Terraform tf bucket with this we created. Here we have this Terraform tf state file, and now in this file at the centralized location it will have all the tf state details. So let me open it. So if you open it, we can see it has started maintaining the tf state in the S3 bucket. Okay. And it also created a DynamoDB table where it maintains the locking. So this we already created last time, only the values will be there, the tables. Okay. So it maintains internally, we do not need to look much into it. Okay. So